In section 6 of chapter 13, we cover interval estimates or prediction. In the previous section, we obtained the regression output using Excel, relating sales calls with copiers sold, and obtain the equation shown here at the bottom that the estimated values of y, in this case copiers sold, equals 1998 plus 0.26 times x. Now I can put here on top the equation equals B38, that is the coefficient, and I'm going to fix that, plus B39, and B38 is the intercept, and B39 is the coefficient of x, or the coefficient of sales calls, which I'm going to fix too, times the values of x. And I'm just going to put before, which is something we have done before. Let me click enter and I get my, let's see, this is predicted values, predicted sales. And if I copy this, I get all the predicted values for the order axis. Now in this section, we learned that we can use the predicted values from the regression using this sample of 15 sales representatives. Remember, this is a sample coming from a bigger population. So we can use our results here to predict or to provide an interval estimation of the population copiers sold average. So we can estimate the average of copiers sold in the population by providing a interval. Now the formula that is used is shown in your book. It's right here, repeated. I just copied it before to avoid, to save time. This is equation 1310 on page 456. The confidence interval of the average value of the population Y, usually in statistics, the capital letters are assigned to populations and lowercase to sample. So we estimate the average value in the population, in this case, the average value of sales, and we use this formula for a specific value of X. And the value that is selected is 50. In other words, what happens if somebody makes 50 calls? Okay, what would be first the predicted value? Well, we don't have a value here, but it's very simple. We just we can calculate it by just putting a 50 here, and notice I get immediately my predicted value. Okay, that is 33.01125. And so that will be this value here. And then my plus minus a t-value. Well, a t-value has to be, since it is an interval, confidence interval plus minus, this is a two-tail that we use. At the 5% level, okay, our upper tail is going to be 0.025, and the degrees of freedom used are going to be 15 minus 2, n minus 2, 13. And you can calculate the value here. We have done it before. We can do it again. Critical, or let's just call t-value in this case. What is it going to be? Well, we can calculate it. Remember, we're calculating t, so we type t.inv. Well, it says two tails already here, so let's select two tails. And in this case, we just specify the alpha, 0.05, and degrees of freedom 13. Now we could have obtained the same value, in case you have a little confusion here. We could have obtained the same value by just putting TDIST, and in that case we use the cumulative of area to the left, and sorry, IMV, and we use the area to the left. Since it is 0.025 on the upper tail, it should be 0.975 on the lower tail, or cumulative area. And then degrees of freedom 13. Oops, I put 2 degrees of freedom 13. Notice it's the same value, okay, 2.16. So we use here 2.16, so let me replace these values here. This is 33, the predicted value is 33.011, plus minus t is 2.16, and this value, 2.16, is going to be multiplied by the SYX is the standard error of the estimate, and in Excel is this value right here, 6.72. So let's put here 6.72. And then times the square root of 1 over 15, because we have total n is the sample size is 15, plus the difference between our x that is selected. Remember, this is for a given, a specific value of x, which is 50 in this case, minus the average of x. Well, the average of x is 96 squared. Of course, if you don't know what the average of x is, you can just go to the under the x column here and type average, B4 through B18, and that is 96. Okay, so that is my average. And then we divide this by the summation of x minus x bar squared. Well, we can use Excel to calculate that. Let me put it right here. X minus x bar squared. Okay, so that is my first x, which is B4, minus, let me just put 96, the average, and square it. Since it is the same value, that's 0, they copy to the remaining values here. And those are all these differences squares. And let me sum these values from F4 through F18. And the difference, I'm sorry, the square values summed of these differences square is 25,600. So that is 25,600, which is also shown in your textbook. So that's the denominator that is shown here, the summation of x minus x bar squared. So when you do all these substitutions, then you get 3301 plus minus, then all these numbers multiply, you know, making all this calculation, that's approximately 5.6. So my range of values would be 3301 plus 5.6, that is 38.61. And 3301 minus 5.6, that'll be approximately 27.4, I believe. I may be mistaken there, but that's approximately. Okay, let me be more accurate here. 3301 I'm making a calculation with my calculator here. That is 2741, which is okay. All right, so that is the confidence interval for the average value of sales in the population for an X equal 50 or for 50 calls. This is our 95% confidence level interval estimation. Okay, so we are confident at 95% that the population average will be between those two values. Or, if we do repeated sampling, which is a more sophisticated way of saying it, then 95% of the samples will include the population mean between these two values. Now, the second part of this is the confidence interval that we develop to predict the interval of y given x. The difference in this case is that we are predicting a value of y for somebody who makes 50 calls. We're not trying to estimate an interval for the average value in the population. We're just saying if somebody makes 50 calls, what is the range of values expected from making 50 calls? So in that case, if you follow the illustrations shown in your textbook, let me erase this for a moment. The only difference here is that the formula is the same except that we add a 1 here. 1 plus 1 over n. So that is the second formula. The whole thing is the same. So if you replace all these values, okay, the same values that you saw before, then you're going to get 3301 plus approximately, I think it's 15.6. Okay, so the confidence interval in this case will be different, and in fact the confidence interval in this case is larger. Okay, it is larger. The fluctuation in the values expected is larger, and that is also shown on page 458 in your book. And the reason is because it is for a specific number of calls you can expect to obtain a wider range of values than just predicting or just estimating the average values in the population. Well, I hope you read also the same section, because this is a partial coverage of the most important aspects discussed in that section.